My dear class 11th students, Assalamu alaikum, and I welcome you all to my YouTube channel NCERT Chemistry Classes. Subscribe and share my NCERT Chemistry Classes to take and transfer ideas and solution of Chemistry class 11th NCERT problem 1.6. Yesterday's problem was based on idea of molarity, that is molar concentration of solution, and solution was binary. Solute was sodium acetate, which is a solid solute, and solvent was water, which is liquid. So in yesterday's problem we had solution containing solid solute, and for solutions containing solid solute we use equation capital M is equal to ratio of W2 multiplied by 1000 and M2 multiplied by volume in ml in order to prepare various molar solutions of any solution but containing solid solute. Here what we do, we first do mathematical calculation and calculate the weight of solute which we need to weigh on balance, and then transfer that weight in beaker, dissolve in it required amount of water, and then transfer this solution to 500 ml measuring flask or volumetric flask and dilute it, add it water up to mark in the neck of the bottle. And in yesterday's problem we had to prepare 500 ml solution, so we have to take in laboratory 500 ml volumetric flask, transfer this solution in that and add water or dilute it up to mark. This way we will be able to prepare 0.375 molar solution of aqueous solution of sodium acetate. But in today's problem we have to calculate concentration of nitric acid in moles per liter. We have to calculate concentration of nitric acid in moles per liter in a sample which has density 1.41 gram per ml and mass percent of nitric acid in it being 69%. Actually, if I will make you understand this problem is also based on molarity, that is molar concentration of solution, but in this solution our solute is liquid, that is nitric acid, and for solutions containing liquid solute, equation to determine their molarity or equation to prepare different molar concentrations of such kind of solutions containing liquid solute is molarity is equal to 10 into density into mass percent divided by molar mass of solute. Remember this thing that for solutions containing liquid solute, this is the equation used to prepare different solutions of different molarity but containing liquid solute, or this is the equation which is used to calculate molarity of solution containing liquid solute. And here in this problem, solute is nitric acid, and nitric acid is liquid, and yesterday I told that in binary solution solute is represented by 2 and solvent is represented by 1. Therefore, I will now use this equation in order to calculate its concentration in mole per liter, that is its molar concentration. Molarity is equal to 10 into density into mass percent of solute divided by molar mass of solute. Remember this equation because for preparing solution, for preparing any molar solution but containing liquid solute, you need to use this formula. In order to calculate molarity of any solution containing liquid solute, you have to use this formula, and capital M here is molarity of solution, that is number of moles of solute dissolved in 1 liter of solution or 1000 ml of solution or 1 decimeter cube of solution. Capital D is density of solution, and for this problem density is given 1.41 gram per ml. Mass percent of solute is also given 69%, and some authors instead of mass percent of solute use SA, or some use percent purity. All are same. Either in question mass percent of solute is given, percent purity of solution is given, or SA is given. And molar mass of solute, here solute is nitric acid, we have to substitute numerical value of its molar mass. M molarity of this solution will be equal to, I will substitute given quantities 10, given unknown quantities into density. Density of this solution is given 1.41 multiplied by mass percent of solute, it is also given 69, divided by molar mass of solute. Solute is nitric acid. We need to have idea of its molar mass. It is compound, its molar mass will be equal to its gram molecular mass. If you don't remember its gram molecular mass you can calculate simply by adding atomic mass of all atoms in it. So I will add atomic mass of 1 hydrogen equal to 1 and atomic mass of 1 nitrogen equal to 14 and atomic mass of 3 oxygen equal to 16, and it comes equal to 63. Molar mass of nitric acid is 63, and I have already evaluated RHS side of this equation. It comes equal to 15.4. Since it is molarity, it is molar concentration of solution, that is number of moles present in 1 liter of solution, so unit will be mole per liter. And we were asked to calculate concentration of nitric acid in mole per liter, which is unit of molarity of solution. Therefore, our answer is, our solution is, molarity is equal to 15.4 mole per liter. If I compare yesterday's numerical problem and today's numerical problem, both were based on molarity, molar concentration of solution. In both, solution was binary, comprising of solvent water represented by 1 and solute was different. In yesterday's problem, solute was sodium acetate, which is a solid solute, and in today's problem, solute is nitric acid, which is a liquid solute. And for solutions containing solid solute, we use equation to calculate molarity of solution as M is equal to W2 multiplied by 1000 divided by M2 multiplied by volume in ml. But for solutions containing liquid solute, the equation that we use to calculate, to determine molarity of such solutions is molarity is equal to 10 into density into mass percent divided by M2. Instead of mass percent, you can also write SA, or you can also write percent purity. D is density of solution and M2 is molar mass of solute. If in lab you are asked to prepare solution of any molarity but containing solid solute, you have to use formula. You have to use for this formula: M is equal to W2 into 1000 divided by M2 into volume in ml. But if in laboratory you are asked to prepare a solution of liquid solute, that time, if in laboratory you are asked to prepare solution of any molarity but containing liquid solute, that time you have to use this formula: molarity is 10 into density into mass percent of solute divided by molar mass of solute. And here what you have to do, you know what molar solution you have to prepare, you know nature of its solute, hence you know molar mass of solute, you know in what volume you have to prepare, in what volume of solution you have to prepare. Usually 100 ml, 250 ml, 500 ml solution is prepared. So by this equation you have to calculate weight of solute, which we need to weigh on balance, and then transfer that weight to beaker, dissolve in required amount of water, and ultimately transfer the solution to 100 ml or 500 ml or 1000 ml volumetric flask, depending on how much volume of solution you want to make. And what here you have to do, you have to first calculate molarity of bench molarity You have to first calculate standard molarity and then use dilution formula. M1 V1 is equal to M2 V2, and then use dilution formula M1 V1 is equal to M2 V2 to prepare solution of any molarity containing liquid solute. Thank you. This is what I have got for you in this short session. Take good care of yourself. See you tomorrow with next problem from this chapter, some basic concepts in chemistry. Allah Hafiz.